In this program, what we're going to be doing is we're going to be performing something called a linear search. So what we want to do is take a look at different things that we commonly want to do with arrays. One is to determine whether an element is in the array and perhaps what position it's in. So we're going to begin by creating an array with 100 elements. So we're going to call it ARR, which is the short form for array, which is usually like when we create an array that doesn't have any real world meaning, we just call it R for short. So it's just going to be a bunch of numbers. So new int 100 elements. And then what we're going to need is we're going to need an element to search for. So we'll create that randomly. And then we'll have a counter, which is going to keep track of how many checks we had to make to determine where the element is. And then we're also going to need this value. And I'll show you what this is going to be used for. So this is going to create our number to be added to the array. Now, what's going to be important is we're going to load an array with increasing, so these are sorted values. Okay? So that's a pretty important element here. So how are we going to do this? So we need a for loop. Whenever we're traversing an array, we typically need a for loop here. And we're going to start at element 0, and we're going to go until just before the length of the array, going one element at a time, of course. Now, here's what we're going to do with new num. So because we want each new number that we add to the array to be larger than the previous number we added, we're going to have this kind of become the current value that we're adding on to the arrays. So we're going to give it the value of new num plus, let's make a random number. We'll keep it relatively small, math.random times 2 plus 1. So what this is going to do is it's going to add either a 1 or a 2 onto the new number. Okay. Now what we need to do is we need to store that in as element I. So array element I is going to get the value of our new number. Yep. New number. There we go. So just to verify that this is doing what we want it to do, I'm going to copy and paste. And I just want to do a test print of the values. So I'll take off this stuff, and all I want to do, system.out.println, we'll go array element I, just to see like what is being created here. So we should get increasing values, and each value is 1 or 2 larger than the previous. So you can see it grows by 1, grows by 1, grows by 2, grows by 2, and it should continue in this pattern throughout. Okay. Now, how are we going to find a particular element? So, you know what you can do is turn this into a comment here, because we might just use this for like testing if we need it. Okay. So let's create our element that we're going to search for. So we want this to be a random number. But what we're going to do is we're going to pick a random number from the very first element that is in the array up to the largest element in the array, which is going to be the last one. So we're going to use the random number formula. So math.random times, and then we're going to go our classic high minus low plus 1. So what is the highest value that we have? So that's going to be array. Now, which element of the array? It's going to be the array.length minus 1, which is the last element. We are going to then subtract the first element, which is the smallest value in the array, ARR0, and then we're going to add 1 to it, plus 1. Okay? Now we want to make sure that it is not from 0 up to 1 less than the maximum. We want to go from 1 to the, or I suppose, you know what, the low element would be whatever is in array sub 0. There we go. So this is high minus low plus 1 plus the low value. And we get our element that we're going to search for. Okay, now what we're going to do is we're going to perform our linear search. So what we're going to do here is we're going to traverse from the beginning of the array to the end of the array, and then we'll see what we get. So I'm going to set my counter equal to 0 here right before I get the array started. Sorry, before I get the search started. I've been using this for loop, so I'm going to continue using the for loop. There's the alternate method that you may have seen in a previous video. Because we really need to keep track of what the index is that we're currently looking at, we need to create it this way. Okay. So every time we check, first thing we're going to do is we're going to increase the counter. So even on the first one, the counter will be 1. Now we need some if statements. So if the array element I is what we were searching for, so we've found the thing we were looking for, we're going to do a couple things here. So system.out.println search for, and then we'll write found in position plus I. There we go. And now what I want to do is I want to print out how many checks it took us to find that. So system.out.println counter plus checks performed. And once I've found it, I don't want to keep going through the loop here, so I'm going to break out of our loop. Now again, only use break when you have a reason that you need to skip out of a loop. Don't sort of make it like a while loop condition, but in here it makes a lot of sense. So if we find our element, we're going to say where it was found, and then we're going to say how many checks it took to actually find it. Our second condition here is, what if we get to the end of the array and we haven't found it? So if I is equal to array.length minus 1, because remember, we're never actually going to get to the length element, we're going to print this in a little bit of a different way. Okay, so instead of saying where it's found, we're going to say it's not found. And we're still going to say how many checks were performed. Now, we don't need a break here because this is automatically going to be the last time that our loop runs. So let's take a couple runs and then see what this looks like. Remember that we won't be printing all of the elements again. So 77 was not found. 100 checks performed. This makes sense because we've got 100 elements in our array. I'm going to run it again. Hopefully it will give us one we find. There we go. It found 153 in position 96. So note that it will take 97 checks in order to do this. So this is going to bounce around a little bit. Oh my gosh. I'm going to, yep. Run that again. Okay, so 14 found in position 7. It makes sense, a smaller number, and 8 checks performed. Now, the one thing that's really annoying here is whenever it doesn't find the value, which I'd love for it to show up again. There we go. Whenever it doesn't find the value, it always performs 100 checks. Now, we can actually do a lot better at this because if we're looking for 132 and it gets to like 133, 135, whatever the numbers keep growing, you know it's actually not going to be in the back end of the array. So as soon as you pass the number, you can stop looking. So we can optimize this. Always an important step when you're writing an algorithm to solve a problem is optimizing it. We're going to check to see if the array element that we're looking for is larger than the number we're looking for. So like if we're on array element I, what is this, 132, if it notices that the number we're looking at, 133, is larger than the number we're going to look for, then let's break out of this loop in a similar way. So I'm going to do this. Still not found. Going to be a smaller amount of checks performed, but we're going to break out of the loop. So now we don't have to go 100. So 123 not found. Now we only need to perform 89 checks for this. So this is a pretty straightforward way of searching for an element. There are unsurprisingly much better algorithms for this that optimize it well beyond adding this little step. So you're going to see that in the following video. It's called a binary search, and I hope you check it out.